Hello class, welcome to Basic Electronics class. Hello class. So today we are going to start operational amplifier. So in this lecture I will be discussing the basic idea. I will give you the basic idea about the operational amplifier. So if you see the word operational amplifier, operational means operation. Okay, so it will do the operation like addition, subtraction, integration, differentiation, which are basically mathematical operations. And amplification means it will amplify the input signal. So basically an operational amplifier is used to amplify the signals, and it can also do the mathematical operation like addition, subtraction, integration and differentiation. So operational amplifier consists of a number of differential amplifiers and we achieve the amplification by different stages. Okay. So basically a practical OPAMP is available as a single IC which is made up of large number of transistors, resistors and capacitors. And basically this operational amplifier is used as an amplifier. It can also be used as an oscillator. It can be used as a comparator, and definitely it can be used as a mathematical operator. So it has a wide application in different fields. So this is a simple diagram of an OPAMP, and an OPAMP has two input terminals. Okay, so this is, I have written here minus, so this is known as the inverting terminal, and here it is written plus, means it is the non-inverting terminal, and it has an output. So we give input signals from these terminals and we obtain the output signal from here. So this is the equivalent circuit of an OPAMP, means the internal structure of an OPAMP. So you see these are the two terminals, input terminals. This is your inverting terminal and this is your non-inverting terminal. So I have written here V1 and this is V2. Okay, so the difference between the two input voltages will go as the input voltage to the OPAMP. So it can be denoted by VD. Okay, VD means it is the difference between V1 and V2. Now this is the input resistance. Okay, so Ri is the input resistance. Then this is my R0, this is the output resistance. So this is the positive power supply terminal and this is the negative power supply terminal. Now this is my V0, that is your output voltage. Okay, so what is my input voltage? Input voltage is the difference between the inputs. Okay, means it will be V2 minus V1 or V1 minus V2. Okay, so this is my input voltage, the difference between the two. So what is gain? Means how much times the input signal will amplify. So gain equals to, it is denoted by A, it is output voltage by input voltage. Okay, so what is my input voltage? It is V2 minus V1. Okay, so hence if you put V0 over here, so V0 will be how much? V0 will be A into VD or A into V2 minus V1. So this is the equation for the output voltage for an OPAMP. Okay, so now let us see that in how many ways we can give input signal to the OPAMP. So in two ways we can give. One is called as single-ended input and the other is double-ended input. So first let us see what is a single-ended input. Okay, so in this diagram you see that this is my negative and this is my positive, means this is my inverting terminal and this is my non-inverting terminal. So we are giving input signal to the inverting terminal. Okay, and I am not giving any input signal to the non-inverting terminal. So when I am giving a input signal to the inverting terminal, then what output I will obtain? I will get an amplified output, but it will be reversed. Okay, or there will be a phase change of 180 degree. So when there is a phase change of 180 degree of the input signal, then it is called as inverting amplifier. Okay, now in the second diagram you see I am giving input signal to the non-inverting terminal. Okay, I am giving input signal to the non-inverting terminal, and what is my output signal? So the output signal is only amplified, but there is no phase change or it is not inverted. Okay, so this is called as non-inverting amplifier. So these are the two types of single-ended input op-amp. So now let us see what is a double-ended input op-amp. So it can be of two types. See, in this diagram we are giving a single input VD, okay, and it is going to both the terminals, to the inverting terminal as well as to the non-inverting terminal. And in this diagram we are giving two separate voltage sources to the inverting terminal and to the non-inverting terminal. So there are different modes, so there are different ways in which we can give the input to the operational amplifier. So in more detail we will discuss about this in the next lecture. Thank you for watching the video. If you have any suggestions or any doubts, you can put it in the comment line.